Okay, so today, as I said, everything stays the same. The only difference is things get a little bit more complicated. So you'll notice in problem number 1, we're still doing what we've already done. We're solving an inequality. We're going to graph it when we're done. The difference is, notice I've got x's on both sides of the inequality. And remember, these are inequalities, not, what am I doing here?
Equations.
Thank you, not equations.
Okay.
So, just like if it was an equation, I want to get all the x's to one side of the equation, of the inequality. So I'm going to add 3x to both sides. Or do you want to add 5x?
I'll do 3x.
3x, okay? All right. So that's 10. That goes away. Symbol stays the same. 4 minus negative 5x plus 3x is negative 2x. Okay. Move the 4 to the other side by subtracting 4 from both sides. I get 6 is less than negative 2x. Then what? You started strong there and you faded off. Divide by negative 2. But I'm dividing by a negative number, so what must I do? Flip the sign. I'm running out of space here, so we'll bring this up here. So it becomes 6 divided by negative 2 is negative 3. Change the sign, x. What's my critical number? Negative 3. So solid dot or open circle? Open, because it's greater than. So we'll put negative 3 over here. Negative 3, negative 2, negative 1, 0. Put a 0 in there. And then let's pick a number over here like negative 4, negative 5, negative 6. Now we have to decide which way it's going to point. Emily, what number do you want to use? 2. Is negative 3 greater than 2? No. So you picked a number over on this side, but it gave you a false statement. So therefore, which way should I shine? Should I? What is that word? Shade. That's the word I'm looking for. Shine, shade, same thing. That way, right? Correct. Okay. Beautiful. What do I need to do first in number 2? Distribute. Negative 1/2 times 6x is negative 3x. Negative 1/2 times negative 8 plus 4. Greater than or equal to 2 times 3x. 6x. 2 times 2. 4. You want to move the 3x over here, or do you want to move the 6x over there? Caroline, what do you want to do? You want to move this one over here or this one over here? Okay, so add 3x to both sides. That goes away. 4 is greater than or equal to 9x plus 4. Get rid of the 4. Uh-oh. 0 is greater than or equal to 9x. Are we worried about this yet? Yes. No, shouldn't be. What's the last step? Divide by 9. What's 0 divided by 9? 0. 0 is greater than or equal to x. What's my critical number? 0. Open dot or solid open circle or solid dot? Solid, because it's a greater than or equal to. Andrew, what number do you like? 5. 5's over here, right? Yeah. Is 0 greater than or equal 5? 5, I should say.
Greater than?
No. What? Listen again. Is 0 greater than or equal to 5? Yes or no?
No.
No. So therefore, the number you picked is wrong. We want to go the other direction. Pregunta?
Yeah. I'm confused. Like, how do you know if it's like an open circle or like a shaded circle?
If it's a greater than or equal to, or a less than or equal to, in other words, if it's got the little dash under there, say it's solid. If it's just greater than or less than, then it's open, because it doesn't include that number. And again, nothing new there. We're just making things a little bit more complicated. All right, number 3. We'll use green. Damien, what are we going to do first?
Subtract 3y with 7, negative 7.
Why?
Because you want to
No, I meant, no. No. You said negative 7, it's negative 7y. I wasn't asking you a question, I was finishing your statement for you. So what's 3y minus 7y?
Negative 4. Y.
Thank you. Can you see that green? It's kind of cool. Okay, you want to move the 4y over here, or move the one
Move
over?
the 4y on the right to the left.
Move this one over here.
Yeah.
So add 4y to both sides. Negative 4y plus 4y is
0.
0. Uh-oh. The y's went away. Now what? Did we screw up?
No.
No? What does that mean?
Undefined.
Why?
Because you can't bring.
Not true. Nope.
There's no y.
That's okay. Is 0 greater than or equal to 5?
No.
No. No solution. It's not true. I'm guessing in number 4, we're going to get a different scenario. So let's solve number 4 and see what happens. Lily, what would you do first in number 4?
Distribute.
Okay. So you get,
4x minus 12.
and then on this side,
Combine the like terms, so you get 4x plus 5.
okay, and you can see what's going to happen here if I subtract 4x from both sides. I get negative 12 less than 5. Is that a true statement?
Yes.
Yeah, so how does that graph? Notice there's nothing on this graph because there's no possible solutions. How do I handle this one?
Well, you need to like go to negative 12 and then 5. No.
No. Does it? What values of, well, let's back up here. What values of x work?
4.
Nope,
Nothing.
none of them. Doesn't matter what you pick for x, it doesn't work. What about here?
Negative numbers.
And?
Opposite of 0.
And? 0.
Numbers less than 5.
How about all the numbers? When the variables drop out, one of two things is going to happen. It's either going to be undefined, which means there's nothing on the graph, no possible number works, or if you, so this is a false statement. So if it's false, there's no solution. If you get a true statement, then it's going to be, remember that symbol, what does that stand for?
All real numbers.
All real numbers. Okay, so the entire graph. There's no critical number. They're all critical numbers. That's kind of the bizarreness that happens sometimes when you're doing inequalities. We saw the same thing when we did equations, when we would solve and get something like 5 equals 5. That's a true statement, so it's all reals. Or we'd see something like 0 equals 3. It's not true, so none of them work. Okay, number 5. Write and solve an inequality to find x. The area is greater than 50. We're going to assume that that's a rectangle. How do you find the area of a rectangle, Sam? Base times the height. So 4 times the quantity, x plus 5. And what do I know about that value? Sam? Oh, sorry. Correct. But I don't have an equation or an inequality yet.
It's greater than 50.
Beautiful. There's my inequality. Now we go about solving that. Okay, then what did you say the first step was, Sam?
Distribute.
Okay. 4 times x is 4x. 4 times 5 is 20. Subtract 20 from both sides. What's 30 divided by 4?
7.5.
7.5 or 15 over 2. We'll go with 7.5 only because it's a word problem here. 7.5 what? Feet. Yeah.
If you were supposed to like graph that, would you just go about it the same way? Or
Yeah.
would you do
You want to graph it?
No.
No? Too bad, we're going to graph it anyways. What's the critical number? Open circle or solid dot? Open. And which way does it point? Pick a number. Were you raising your hand or showing me 5? 5. Okay, so 5's over on the left. Is it true? Is 5 greater than 7.5? No. So that side is false, so we shade it in the other direction. It didn't ask us to graph, but if we did, that's what it would look like. In this case, we actually want just the inequality answer there. Let's go back on that. No, beautiful. All right. Same stuff we did yesterday. Like I said, it gets a little bit more complicated, and you've got these two pesky little guys to deal with when it's no solutions or everything on the number line. Don't forget to make sure it's clear whether your circle or whether it's an open circle or a solid dot. Don't do something like this. Well, no, that's an open circle. Oh, no, that's a solid dot. Okay, make it quite clear. Solid dot, completely colored in, open circle. In fact, make them obscenely large so we can tell where they are. Okay, find the critical number, solid dot or open circle. Make sure you point it in the right direction. And again, I like to figure out which way it's pointing by testing numbers. You can try to work it out logically. For instance, I want all the numbers greater than 7.5. It's up to you. Whatever's going to work best for you. Okay? Homework then. Let me stop this.